Hi guys, so I'm going to run through with you how to test all parts of these kind of older style points and condenser ignition systems. I'm going to talk you through how to check the primary and secondary windings. I'm going to talk you through how to check for charge, discharge and holding of a charge, as well as capacitance of a capacitor. We will go over talking about conditions of wires, what can happen when they're not in good condition, and we'll just discuss points and we will go from there. But I've actually done videos on each one of these. However, I'm going to condense it into a single video. I'm working on this at the moment, regardless of whether it's a car, small engine or a chainsaw, etc. It doesn't matter. Principles are very, very similar. So the first thing, in fact, let's start with this. Now, I haven't done anything here. All I've done is cleaned it and taken it apart. I don't know any of the readings, so we're going to do it together. I'm going to talk you through it. What I have done is, before I started this video, I took the manual. Actually, I say open, it was actually on my phone. Took the manual and I have found out the readings for all the different parts, the primary and secondary, the capacitance, etc., etc. And we will go through that. So, first thing, we've got the capacitor in front of us. Testing a capacitor is pretty simple. There are a number of tests though, and you should do each one of those to make sure that the capacitor is good. And if it fails in any point, then the capacitor should be changed out. Sometimes, even if the capacitor is reading wrong, you may get the engine running for a while and then all of a sudden it will start to die out. You're wondering what's going on. Generally, this is your culprit. When things get hot, this is generally your culprit. Sometimes it can be the ignition coil, but on these older styles, it's generally here. So, first thing we're going to do, we're going to take our multimeter, make sure that everything's clean, there's no oil or grease over anything here, that it's all good. And we're going to go on to capacitance. Okay, we're running in nanofarads. I'll just make sure these are both clean. That's good there. That's good there. And I have got a bit of brake cleaner that I can just run over. Let's see if there's any. That's fine. That's fine. And then we'll just go onto the side here. Make sure that's clean. So we've got ground, or at least we've got a good connection between a lot of them. So first one is we're going to go from the wire here, this connector, and we're going to go to the side of the capacitor itself. Now for this one, we're looking at around about 150 to 200 nanofarads. Now you generally have an allowance of about plus or minus 20%, give or take. It doesn't have to be absolutely bang on. We will see. It will almost tell us straight away. 7. Okay, we're so far out on this one. 7.75 nanofarads. Yes, that is incredibly low for this. We're like, yes, nowhere even close. Okay, let's just let's make sure that we're not having any issues here. Let's just go straight on to this soldered point. Let's try again. Maybe it was a fluke, maybe it wasn't. No, it wasn't. Oh no, we are so far out. Okay, that's a telltale sign there that we're going to have issues with this. Okay, so that's the first test. We're going to test for its capacitance. Should be 150, 200. We're about 8. Then we're going to move on and we're going to see if it takes a charge. We want to make sure it can take a charge and that it does so efficiently, quickly. It should almost be instant. Okay, so we don't want continuity. There's not enough energy if we go via continuity to charge the capacitor. So we want to go on to resistance. So if these touch together and they bleep, we're on the wrong setting. We're on continuity, we want resistance. Okay, that's wrong. Press select, shouldn't make a bleep. It doesn't, shows us. And then what we want to do is make sure that we have 0 resistance in this winding. 0.1 is absolutely fine. You'll probably find if I move it slightly, you'll go down. Even if you've got 1 ohm of resistance, just subtract that from your reading. Oh, telephone call. Hold tight, guys. All right, we're back. Sorry about that. Where did we finish off? We were together. I had to turn it off. Right, we have done capacity. We go resistance. So these will make a bleep. Press the select button. We're going to go to our resistance rather than continuity. And we just want to make sure it's 0. I think that's what we were saying. If you've got 1 ohm of resistance throughout this circuit or something, it doesn't matter. Just subtract the 1 ohm resistance. It's probably just a bit of dirt. Maybe your wires are a bit cheap. Doesn't matter. I did find that I bought a spare set of wires and I found that They just weren't quite as good. Anyway, we're fine. So what we want to do, we're charging the capacitor now. Oh, we don't want to press that on there. Get that off. And now we're going to go to the side, and we want to make sure it takes a charge. Now, it should take literally a few seconds to fully charge up, and it should go straight to open loop. We don't want to have high resistance when this happens. So, same again, to the side. Where are we? Huh. It's obviously, it's charging it. It is charging it, but it's we're on mega ohms of resistance, a huge amount of resistance in this capacitor, which kind of is in keeping with the weird readings that we've already had. This should have already gone, and it should say open loop, but it's charging. It's just there's a huge amount of resistance for it to charge. So again, we're miles out. This should have said open loop already, or O.L, and we'd know we're there. So we will have, hopefully, charge in here, but it's going to be very slow, and that is not ideal. What you'll find, did I mention this, Ed? I can't even remember if I mentioned it earlier because I got distracted with a phone call. This was running okay. However, I only ran it at idle for a couple of minutes. If I then got it under good load and everything got a bit hot, you'll find very likely that the spark will disappear. If you've got a spark, if you've got an engine that's losing spark after a few minutes once it's warmed up, it's very likely the capacitor. We're so far out of our reading here. So anyway, that's how you charge. It should, as I said, when you test yours, it should go almost straight to open loop like that. That's what it should say. It's not doing it. Now we're going to move on to volts, and we're going to now see if it discharges. It should be fairly quick, maybe about 10 seconds. So let's have a look. We're currently on AC. We want DC volts. Just the same thing again. Yeah, so it kind of charged up, but it was so slow. Seems to be discharging okay. This is an okay discharge speed. That's pretty standard, bit slow. And we want to make sure it fully discharges. So let's fast forward this. You don't need to sit through this number dropping. So again, it should have been straight to zero already. The last test, because it's so slow, let's just stop it there. We're going to recharge the capacitor, and we're going to see if it can then hold a charge. So back here, we want to make sure there's no bleep. There will be. Okay, press select. We're going from continuity to resistance. We're going to go and give it some juice. And now what we'll do, we're going to go back to volts, DC volts. We're going to do the same test again, but at one point or a couple of points, I'm going to remember the number, and then I'm going to take the probe off. We're going to wait 10 seconds and see if it holds that charge. 150, 140, 130, 120, 100. Roughly. We were around about 100 millivolts. Wait 10 seconds, and if we're within kind of 10 to 20, either way, we're absolutely fine. But generally, wait 10 seconds or so. We're going to go back. We're looking for around about 100-ish. Yeah, we're bang on. And we'll stop at 50. Again, this is normally much more difficult because it's dropping much faster. Yeah, and we're fine there again. So, it can discharge, although it's slow. It's very slow at taking a charge, and the capacitance is very low as well. This is a bad capacitor, and if we were to run this, we're going to have issues. So what we're going to do is move on now, and just a word of warning. I had already discharged this beforehand. I should have mentioned this. Always discharge a capacitor before you use it. These small ones, they'll give you a bit of a zap. It's not the end of the world. It's pretty uncomfortable. You do it with a microwave capacitor, and you will kill yourself. So basically, to discharge a capacitor, you basically ground it out against itself. The top on the side, or sometimes it's a threaded portion, sometimes it's soldered, doesn't matter. Or you could even just take this, ground it out there, and just leave it there for a few seconds, and you'll be fine. Just make sure it's fully ground. Okay, so that's it. We're going to pop that out. It's not working. Moving on. Now we have the ignition coil. Let's hope for better success with the ignition coil, because these are expensive to replace. So ignition coil, they're all generally very similar. They have pairs of windings. They have a primary and a secondary. Primary is generally about 1 ohm of resistance. There's nothing in it. And secondary, for these small engines, somewhere between 5 to 10,000. I've checked in the book before I did the video. We're about 7 to 10,000 ohms of resistance. Or 7 to 10 kilo ohms of resistance. To test the primary, we're going to go back onto resistance, not continuity. So these are going to bleep, and that's not what we want. There's no bleep. We want to make sure that they're 0. There we go. Now, to go to your primary, we have one wire that goes to the points and one wire that goes to ground. We want to connect these two together. Sometimes this is internal. You won't even have a second wire. It can already be grounded out. Sometimes it's soldered down to the armature. And in this case, it's just screwed onto the armature. One word of warning here, whenever we're working with coils or any kind of wires, we want to get as close to in this case the coil, as close to the primary coil as possible. If we're going to clip onto here, there may be resistance in the oh guys, my brain, I've got brain fog, in the connector, and it's going to give us an incorrect reading. So really we want to make sure we're as close to the coil, or if we're not, that the contacts are nice and clean. This is fine for now. It's absolutely fine. I'm going to stick with it. I could go onto the wires, but I don't want to damage them. So 1 that side, and we're looking for around, on this one I've checked before I did the video, 1 ohm of resistance. 1 to 1.5 is where we are with this. So let's have a look. 0.9 ohms of resistance, we're spot on. Then we want to go on to the secondary. Now it doesn't matter which wire we use, whether we go from here to here or here to here. What matters is that we're going through the secondary windings. The secondary windings, in this case, are 7 to 10 kilo ohms, or 7 to 10, and you'll see a K there. So let's take one wire off. They both go through the thing. And we're going to now go from primary to the secondary, which is basically this HT boot. Now, if you're finding you've got some issues and it's not accurate, take the boot cover off here and go straight to the barb, because that's going to be the closest point to the coil. In we go. Should be around 7 to 10. Where are we? 6.8 kilo ohms. Absolutely fine there. No problem whatsoever. We're going to leave it. Don't need to worry about that at all. The last thing to know whenever we're working with any wires is the sheaths of these wires. Well, there's two things: the sheaths or the connection between the wire and what we're connecting it to. For example, if this wire, where it connects to the barb here, I can't get it off because that rubber boot's there, but is a poor connection, then we're going to start to have spark issue, and it's not a problem with the coil, it's a problem with the connection. Same thing with primaries either side. It could be an issue. So if you're finding you haven't got spark, don't instantly just throw the coil away. It might be something as simple as a connection. Maybe it's just the barb inside the boot, maybe it's just a connection here onto the coil, maybe it's something slightly loose. We can search for that, and I'll go over how to search for that in a second. The second thing, of course, is the sheathing. These get hard and brittle. These plastic sheathings get really hard and brittle over time, and once they get a bit of vibration, constant vibration, they can start to crack. We can test it, however, it really needs to be onto the saw itself or onto the engine itself, and we basically would disconnect it here, make sure that it's not touching ground anywhere at this end. We'd put one probe onto here, and then one probe onto ground somewhere on the housing. If we're getting continuity there, we know that somewhere along this line, it's damaged and it's going to ground. That will kill your spark right away. Let's check the other one. We've got a kill wire. Now the kill wire is very simple. That's essentially all it does. In this case, it goes from the points to... Well, it can either go from the points or it can go from the capacitor. I've had both, and it doesn't matter. It makes no difference. You're basically just trying to give it a direct run to ground rather than having to clear the gap in the spark plug. But essentially, in this case, we're connected to the points here. And as soon as this goes through a switch, now it does depend on how the switch is set up, but generally it's just a case of when the switch is off, that this goes to nowhere. When the switch is switched on, it creates a short to ground, so then this can then go to ground, and it doesn't then need to jump the spark plug gap, and it will always choose that route, and that will kill your engine. So let's just have a quick look at this one. Again, it's hard. I'll probably just there. Look, there we go. Let me zoom you in. Can you even see? Can you see that there? Broken. This is a perfect example. If that's touching part of the housing of the engine, then you're never going to get spark. So this could very well be one of the causes of why this saw was put out of use, is because it didn't have spark. Could be that, could have been the capacitor, could have been one of these connections. These wires are actually dirty as well. So we're going to replace that. Put that to one side. Let's zoom you back out. And then we're going to move on lastly to the points. So points are generally the same across the board. Sometimes they'll give you the points gap on the actual thing itself. Sometimes there's like a little gauge that you can then disconnect and slip in there. But when we're looking for points, we want to make sure that the shaft is nice and greased. We've got some oil on there, some grease on here, and we want to make sure the points are nice and clean. Don't go overboard, because what you'll find is for example, if you've put some grease on the crank and it's spinning, you put excessive amounts, it can fling around, it can get inside the points, and you can find that you're not getting spark that way. So always make sure these are nice and clean. We want to check to make sure that they're not burnt up. These are a little bit dirty, so we'd put a file in there, we'd clean them up. But actually, there's a lot of life left back in these points. So what we can do to test points is we'll go on to continuity is a really great way of testing the condition of a wire to see if it's going to ground. And it will give you a very small amount of energy, and it will give you a bleep. And this is great when we're over here and we can't see the multimeter. If we're far away from it, we can just hear that audible tone. So let's use that as an example. So we can't see the multimeter. We're going to test that we've got a bleep. Okay, we know we've got continuity here. These should have continuity, so we're going to go on to here. This, of course, has to be clean. And then we're going to go on to here, and this should bleep. Oh, sorry. There we go. Hold tight. Okay, we're connected here, but what I'm noticing is it's not really a great connection. Now, that's not to say that there is an issue. It could be the points. It could just be where, if we look here, it could be as simple as the fact that this bolt, where it presses against the spring, is not making a good connection. So let's try this. Let's see if it improves here. I'll move it around. That's much better. So in that case, it was just the bolt. So what it's saying is these points are good. How good, we don't know. We want to just check. And really, it should be 0 ohms of resistance. So let's bring it back over now. 0 ohms of resistance. So what that's telling me is that when the coil's being energized, we can get free-flowing current going through the points, and that's no issue. But now what we want to check is when they break, do they break cleanly? Is it instant? Is there any issues? Is there any resistance in terms of the movement of this armature of the points? We will see. So we're going to go back on. It should bleep. And we want to check that it breaks straight away and that it comes back. It's like Morse code. Anyway, it does. It's doing it fine. So all I'll do with these points is I'll just clean up in there. I mean, we're getting zero resistance, but we're just going to clean up in there anyway. And that is it. That is how to test for primary and secondary windings, testing wires going to ground. It's the way we test the coils to make sure that the capacitor, just make sure whenever you work on capacitors that you always ground them out before you start, like this, basically touching the top and the sides together. Leave it there for a few seconds, move it around a few times because maybe you're not making connection. Small capacitors, you're fine, you're just going to get a good old zap. Larger ones, it's very serious and you can absolutely kill yourself. There we go. Hope you enjoyed it. That was a lot for one video. Multimeters are really an absolutely essential part of diagnosing problems throughout the whole engine, but especially on these sorts of things where we're testing coils and capacitors, blah, 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 blah. So there we go. Hope you enjoyed it. Word of mention is this is testing old points ignition coils. This is not testing new ones. The new ones have circuitry within these coils. And the long and short of it is, although I've had good success testing them, you may find that actually you're not getting the right readings and you might throw the coil away when actually it's absolutely fine. So there is circuitry in modern coils. We don't want to test them with a multimeter. That's only for these older style points ignitions. If you want to test a new style coil, you have to energize the coil, and that's the way you do it. You can get a proper tester, but they're a lot of money. Not necessarily in this case, but there we go. Generally, if it was just me and I lost spark and I tested everything else and everything else was fine, I would probably say, well, we've got a problem with the coil, and that's when I'd change it out. I wouldn't spend $1,000 or however much it is, 600, 500, I don't know how much it is. A lot of money to get a proper tester that can actually energize the coil. You plug it into a main supply. This case, nice and simple. That's how we deal with it. So what I'm going to do is I'm going to put a new wire in here. We're going to put a new wire here. We're going to use a new kill wire because that's damaged. And I'm going to put a new HT lead in there as well. And we can check the connection and check that the barb and all that's good. And clean off these grounds before we put it back together because we want to make sure that we've got good connection between the armature because that's where that grounds out to, and where we're going to connect it onto the engine itself. So there we go. Hope you enjoyed it. Hope that helped. Hope that gave you some ideas as to how to test these things. And yeah, we'll leave it at that. All right, guys. Catch you later. Bye.